Hello, this is Clint Halstead, and this is an internet course called Introduction to Microprocessors. And we're using the book that you can see here on the screen. And we're currently on Chapter 5, 5.6 Logical Instructions. So, with this lesson we're going to learn 8 logical instructions. The first one is AND W to F. We're going to go over each one of these in the simulator and give some examples in MP Lab X so you can see how they work. But basically, this is a logical AND instruction, which does a bitwise AND. So for bit, it'll do an AND. So if you have a 1, 1, that gives you a result of 1 in that bit location. For example, bit 0. If you have something loaded in F, whatever your file register is, let's say, for example, you have 0, 1, 1, 0, 1, 1, 1, 0, and if this is in a file register F, which could be anywhere, you have to, of course, F is going to be equal to the address, and then this is the data, so you have the F address location, maybe 0x20, for example. That could be the address, so you put that here in this instruction. So you would put 0x20 here, or you put a label. So it's going to take whatever's in the W register and AND it with F. So this is what we call the operand. Now, so for example, let's say that W happens to be loaded with 1, 1, 1, 1, 0, 1, 0, 1. Then when this gets ANDed, let's erase this so we can do this operation. So when this gets ANDed, then you're going to get 0 and 1 is 0 and 1 is going to give you 0. So you have to have a 1 and a 1 to get a 1. So 1 and 0 gives you a result of 0. 1 and 1 gives you a result of 1. 1, 0 gives you a result of 0. 0, 1 gives you 0. So you have to have 2 1s in order to get a 1 out. That's basically the way the AND operation works. So that's the result of that operation. So hopefully that one is clear. Okay, so the next one is inclusive OR. Inclusive OR is just regular OR. Most people have just heard it as being OR. There's an exclusive OR and there's an inclusive OR. And hopefully from basic digital electronics you know what those terms mean. If not, then I would go research the OR statement. I'm not going to go over that here in the microprocessors class. So if you really want to know what the OR statement is, I would recommend to research that on the internet. So this is an AND operation. Let's see what this OR, the result of this OR would be. Okay, so this was the AND result. Let's go ahead and do a quick OR. Okay, so the I OR WF, again, you put the location of the address for the file register. So wherever this file register is located, you put its address right here. And it's going to OR whatever's in the W register to the address. So in this case, it's going to say a 0 or a 1 gives you a 1. 1 and 0 gives you a 1. 1 and 1 gives you a 1. So as long as there's a 1, now let's give a case where actually there's a 0. So anytime you have at least just one 1, then you always get a 1. So in this case, if you have a 0 and a 0, then you get a 0. So that's the only case you get a 0. So let's do, okay, so how about rotate F left through carry? So this is rotate left. So how does that work? Okay, so and then you put the address for the file. Of course, you have to have the file. This is only operate on a file location. So let's get rid of this stuff. So let's say we have a file register that looks as follows. Okay, then if you rotate to the left, it's just going to shift everything over to the left. So of course, it depends on what you put in this location here. So if you put, you have a destination bit here as well. So actually you have the same thing on all of these. These all have a destination bit. I forgot to mention that before. Now remember, the destination bit, if you have a 0, then the result goes into the W register. If you have the destination bit equal to 1, then it goes into the file register. So let's do an example here. Let's assume that we have a D equals 1, so this is the address location of this file register, and then you have D equals 1. Then the result would shift everything 1 bit to the left. 1, 0. Okay. So that's the way it works. It shifts everything over to the left by 1 spot. Hopefully that's... Oh, actually I don't think I did that right. Sorry. This 1 goes here. This 1 goes here. This 0 goes there. 1, 1, 1, 0. Okay. So now it looks good. Sorry about that. Okay. Now let's do an example of the next one, which is rotate right. So again, the same thing. You have your address and you have your destination bit. So let's go ahead and clear this one. So if you shift to the right, everything's going to shift to the right by 1 spot. So you're going to have this 0 goes here. This 1 goes there. 1, 0, 1, 1, 1. And then of course it has to fill in with a 0. So that's the way it works. Pretty simple. Exclusive OR, again, you have to know your basic digital logic. Again, that's a different class, so hopefully you can go research that on the internet if you don't know what exclusive OR is. Just Google that and figure out what that means. Now I'll give you a quick example. So exclusive OR, you have to have something in the W register in this case. So let's just assume that we have something in the W register here. Maybe let's just fill the W register with all 1s, except we'll put a 0 there. Now exclusive OR gives you a 1. It's just like an OR, except for it excludes the case where you have both 1s. So typically in an OR statement, anytime you have a 1, you always get a 1. So in this case, you get 1, 0 gives you a 1, 0, 1 gives you a 1, 0, 0 of course gives you a 0, but a 1, 1 gives you, typically in an OR it would give you a 1, but an exclusive OR excludes that 1, 1 case. So the 1, 1 case is excluded, it gives you a 0. So let's show how that works on F and W in this case. So 0 and 1, it works just like a regular OR until you have all 1s. In that case, you always get a 0. So here you get a 1, here you get a 0, 0, 0, and then here you get a 0. So that's the way the exclusive OR works. And again, it's address and then a destination bit. Now it's the same with the AND. Now the AND works the same way, except instead of having address and destination, you have the literal. You just have a literal value, which means you just put a number here. So you just put, for example, you'd put, let's say you put okay, let's give an example of that. So let's say you go B tick, and you can say 1, 0, 1, 1, 0, 0, 1, 1. And so that's how you do that instruction. So in this case, there's no address, there's no destination, but it's just the result always winds up in the W register. Okay? And then you just use the regular AND. So you have whatever's in W and you AND that with this literal value. You go through like we did before. The same thing for the inclusive OR literal. You just put a value here. 1, 0, 1, 1, 1, 1, whatever you want. Whatever your literal value is. Of course, this is binary. You could do it in decimal or hex or whatever you want. And then you have the exclusive OR literal, and it works the same way. You just put your binary value here, 0, 1, 1, 0, 1, 1, 1, 0. Whatever value you want there. So there are 8 instructions, the logical instructions that we have. And so let's go over really quickly what we're going to go over this example, this exercise 5.9, and I hope that you would go over that in the textbook as well. That would really help you out to step through that code and make sure that you understand how that program works. And so we'll go over this in a minute. I won't talk about it right now. We'll go over it in the MPLabX software. Just wanted to go over really quickly what we've learned so far. Today we've learned all the stars that are in red, and the green is what we've learned previously in the previous units. So if you're just now joining the video, go ahead and watch some of the other units, and you can. This is unit 30, should be unit 31. So just go back on some of the other units and learn how those work. But we're almost done, so we've made a lot of progress here. And you can look at this chart and you can see exactly what gets affected. The AND W to F. You can see that the operands are the file, and you got the destination register, and you can see what status register bits are affected by that. And you can even see how that the code is built inside of the microprocessor. Exactly what the zeros and ones. And then this is the second page of the instruction set. So we've probably got about 90% of our instructions down at this point. So now let's look at the example in the book. Okay, programming exercise 5.9 on page 127. So at this point, you should be able to create your own file. So you should be able to create your own project. I don't want to go over that again. I've showed you how to create your own project several times. So at this point, we're just going to assume that you know how to go to the website, follow the instructions. The website is Embedded Know-How, and I've showed this several times as well. Of course, Embedded Know-How and embedded-knowhow.co.uk, and in the exercise it says go use program example 5.7. So we hit chapter 5, 5.7, and of course you can copy and paste this code into this example. Now what you need to add is this part. You know, you can copy and paste this from your previous lessons. For example, the ping pong program, you can copy and paste the watchdog timer, the config bits, paste that in there, and then you should be good to go. So let's run through this and see, and let's use our knowledge of the watch window. I've already created some watches here, and I'm not going to go over that again either. Hopefully just watch the previous lessons and you can learn how to do that. So okay, so first off, I need to change this back to my simulator because I actually changed it to PIC kit. Let's change this to our simulator by hitting the wrench icon. Let's go ahead and run the project. Okay, now let's pause it. Let's reset it. Now we're at the beginning. Now what we're going to do is we're going to single step through this code, and we're going to try to figure out how it works. Okay? So the first thing is stuff you should know. It's going to just initialize like the same thing that we've been doing on all the other programs. It's setting the port A and port B to inputs and outputs depending on what it needs to be set to. Again, this is using the ping pong hardware. Okay, so it's setting up all your tris A and tris B. Now this is now it finished the initialization. Now you can see we're going to this loop, and you can see that we have basically two call subroutines. And we learned about subroutines. Now we're actually going to use some subroutines. So you can see that this code is pretty simple. We have a call instruction to a pattern, and then we have a call instruction to a delay, and then we just loop forever. This is an infinite loop. So let me just show you really quickly one kind of neat feature. Typically we've been using this step into, which is F7, which is just the down arrow. Now if we want to step over means that it's going to go inside this subroutine and run all the code inside there, and then it's going to, it's not going to step into that subroutine. It's going to do all the stuff that's in that subroutine, but it's when we click the button here, step over, it's going to run everything, but it's going to take us to this next call statement. So let's just click it and see what happens. Okay, so you can see, okay, you can see that it stepped over that instruction. Let's do that again. You see how that works? So that's kind of neat. That's one way to do it. Another way to do it would be to run to cursor. That's kind of cool. So if we put our cursor here, let's say run to cursor. Oh, that's cool. So it did everything inside of the call pattern. Let's actually do that again. Let's step over. Let's do step over. Let's just do. Oh, pause. Sorry about that. Let's do that again. Let's do run to cursor, because we haven't used that one before. Okay, you can see that all the status registers have been updated. Let's do it again. Oh, that's kind of neat. You can see that the port B, notice the port B. Now this is where the LEDs are at. We're going to do run to cursor. Notice that the port B LEDs are going from left to right. Okay? In the port B, right down here. Okay, so that's how the program is supposed to work. Now let's dive into it and see why is it working that way. So let's reset it and go to the very beginning. Okay, so let's run to here, run to the cursor. That initializes everything. Now we're going to single step into this call statement. So when we hit step into, now it's going to jump into that call statement. Now what it says is bit test F, skip if clear, the flag register. Now the flags register we've already defined as being equate 13. So that's actually register 13. So that's down here in our watch window. And we've already taught you how to look at the watch window. Now, because we can't really see what that's called, I actually made this little sticky tab in Windows 7, and I kind of put here some text here so we can see what these registers are. This is the flags register. This is the delay counter 2. This is delay counter 1. So when I click on the screen, it goes away, but I can always just pop it back up by clicking down here. So that's kind of a way to get around the bug that's in MPLAB X right now. So let's go back to where we were at. Okay, so this is going to bit test F and skip if clear. Now the flag register, you can see, is 0. So skip if clear, so it is clear, so it should skip this next instruction. So it should go down to the bit set F. Okay, so let's step into that. Okay, it did skip that, so that's what we thought. Now it's going to bit set F flag 0. So this should go to a 1. Okay, it did go to a 1. Now it's going to move literal to W, B. So it's going to move all this stuff into the B register. I'm sorry, to the W register. So let's step into that. You can see the W register has changed. Now it's going to move that into the port B. Okay, so it's going to set that in the port B, which are your LEDs. You can see right there, we have that's what happened. Now it should return back to where it was called from. So let's step once. Now it's going to call the delays the delay block. So basically, what it did was it went to this pattern, which is rotate right. So it has a rotate right pattern. So it's using the rotate right command. Now there's three different patterns inside of this code. There's an XOR pattern, a rotate right pattern, and an inclusive OR pattern. But you can only run one at a time. You have to actually go up here and change it here to change it to whatever you want it to be. But right now here we're on the delay statement. Let's just step into the delay statement and see what happens. So it goes down here to delay, and it's going to just try to implement a really long delay. Now if you step through this, I'm just stepping through each one at a time. You can see it's going to be stuck in here forever. Okay, stuck in here forever. So let's let's do something to get out of it. Unless we want to single step forever, we could. There's several different things we could do. We could use the run to cursor thing that we used before, or we could set a breakpoint. Let's set a breakpoint. Let's set a breakpoint right here to the beginning of this call statement. That way, if we hit run, it'll go all the way through that delay, and then it'll just always stop right here. That way we can see what happens each time it goes through this loop. Now we could have put that breakpoint anywhere. We could put it here. We could put it there. It doesn't really matter. Just as long as you put it somewhere in the loop. Or you could put it anywhere outside the loop. As long as it's inside the main loop, then it's going to run once and then pause. Now let's see what happens down here to the port B. You can see, I'm just going to keep hitting run, 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 run. You can see what the LEDs are doing, okay? So that's what this pattern does. So it basically just cycles some LEDs from left to right. And actually have this code downloaded into my PIC kit, and you can actually see the way it works here on the screen. The light just goes from left to right. Okay? So now let's try another pattern. There's different patterns in here. Let's try the... So it uses the... I don't know if we really illustrated this very much. Let's run... Let's get rid of this breakpoint. Let's investigate this command, this new command that we've learned. Rotate right F. Let's run to the cursor. Okay, so it runs here. Now let's see exactly what happens with this instruction. Now look at this instruction. It says rotate right F, port B 1. So that means the 1 means store the result. It's going to rotate whatever's in the port B register to the right, and it's going to put the result back into port B. If it was a 0, it would put it in W. So let's step this. So notice in port B, we have, notice the pattern that we have. Now look, we're going to hit step. Okay, did you notice that it went from, the 1 went from here to here, so it went to the right 1 position. So that's, and then it does a bit test F, skip if clear. It's going to test to see if this status register is clear, because it's looking for a carry flag. When this 1 goes out, then it gets a carry. And then it's just going to reset. It's going to set the 1 again to the left again. It's just going to shift on through. So that's pretty much how it works. Let's try a different pattern. We have 3 different patterns inside this code. First, we just did the pattern rotate right. Let's do the pattern IOR. Let's see what pattern that gives us. So up here, we're going to change this to IOR. IOR. And then let's go ahead and run this one. Okay, now let's pause it. And then let's come up here. Let's actually go down inside the IOR pattern. Let's just run. Let's just set a breakpoint. You can do it different ways, but we'll just run to the breakpoint. We'll reset it and then run to the breakpoint. Now you can see that this pattern currently is all zeros. Now it says right shift right, port B 0. So let's step that and see what happens. Okay, nothing really happens because there's nothing in there. Now it's going to inclusive OR literal with W. So you can see that in W there's nothing. So it's going to OR that with 1 0 0 0 0 0 0. So let's step that. Okay, so that gives the result of, it basically gives you a 1 here. Now it's going to do a test and see if there's a carry, which there's not going to be a carry, so let's see what happens. So it should skip. Okay, it did skip. It's going to move W to F, port B. So it's going to take this value and it's going to move it to port B. It's going to put that, it's going to light that leftmost LED. So let's do that. Okay, that's what happened. Now it's going to return. Now let's run it again since we have a breakpoint. And let's see what happens the next time through the code. Okay, let's see what happens. So port B is the same place it was before because we had a nice breakpoint there. Okay, it rotates right, port B, and it put it in the W register. You can see here that it shifted everything to the right. Now it's going to OR these two together, so it should give you 1 1, and it's going to put the result in the W register. So let's run that, and it did give you 1 1. Now it's going to do a bit test, which should skip. Now it should move W to F. Now it's going to move this pattern to port B. Okay, see there, now you got 1 1. So you can see that this pattern is different. So let's just run this consecutively. and let's look at port B. See how the port B changes its LED pattern? That's a different pattern than before. Okay, you can see that pattern is completely different than before. Okay, so let's download this to the microprocessor and see what happens. Okay, so what we need to do is we actually need to stop this. We need to hit the wrench icon. We need to go to the PIC kit and say OK. And then say OK to this message. Then you need to go ahead and build it. And then download it. It's that simple. Say OK to that message. And let's see what happens. Okay, now you see the pattern. The pattern is different than before. So that's the inclusive OR pattern. So that's kind of a neat pattern. Okay? Now let's do the final pattern. Let's go back to the simulator. So we hit the wrench icon here, and then we click simulator. We say OK. Now we're going to use the final pattern is going to be, what's the final pattern called? It's called XOR. Okay, so let's change this to XOR. This call routine. So this I needs to be changed to an X. There we go. Hit save. Just run it. Okay, now let's pause it. Let's reset it. Okay. Now what we're going to do, we're going to set a breakpoint anywhere inside of here. Let's do it before the XOR command so we can see what's happening with that XOR. So let's run it to there. Let's look at our watch window. Okay, so it's going to move 0 to port B. Now it skipped past this command. It loaded the W register with this pattern 10 10 10 10. So you can see down here in the W register in the W register, that's what we had. Actually, let's run to this cursor. Let's reset it. Okay, reset it and then run. Okay. So let's step through the code. It should move the port B to the W register. Okay, so let's do that. Okay, it did. It's got the pattern 10 10. Now we're going to exclusive OR literal with W. So it's going to exclusive OR all these ones with the W register. So that should, if you go through that exclusive OR logic, you'll see that it should basically make all the ones change to zeros and all the zeros change to ones. Now you can do that on a piece of paper and see that really is true, that that's the correct operation. So let's step through there and you see how the pattern, all the ones became zeros and all the zeros became ones. So that's what that exclusive OR instruction will do. So now let's just run it. I'll just keep hitting run. You can see what the pattern is going to do. It's just going to kind of flip-flop back and forth. So again, that's a different LED pattern. So now that we've done that, let's go ahead and download this one and see what it looks like. So let's click the wrench icon. Oops, we have to click stop. Click the wrench icon, go to the PIC kit 3, click OK. Go ahead and build that. Done. Now let's download it. Now let's just wait. Okay. Let's wait for our pattern to change. Oh, there's our new pattern. So that is the exclusive OR pattern. So thank you for watching this lesson, and I'm going to see you for the next lesson. Thank you so much.